Router components. At the core of router operation, you will find a foundation built on processes, memory, registries, and files. They are collectively known as router components. Each component must fulfill its function to allow for the proper operation of a router. In this nugget, we are going to identify and define each router component by outlining two key processes. First, we'll take a detailed look at the boot sequence, and we're going to follow that with a high-level look at the process of configuration modification. The first router component that we're going to run into when we talk about the boot sequence is called ROM. Now this stands for Read-Only Memory. I'm sure that you're familiar with this from other devices that you may have had experience with. Your computer is going to have a form of read-only memory as well. Now keep in mind that read-only memory has many functions within the Cisco router. Two of the processes, if you will, that happen within the ROM are post and bootstrap. And with these two combined, we can see that ROM is responsible within a Cisco router for the initialization of that device. Now, there are other functions within ROM, and we're going to see later where it can be used as a safety net and also a platform for downloading iOS images. At this point, let me get you familiar with our diagram. What we're going to do is we're going to assume that we're going to start with the router in the off position here on the left side of our diagram. We're going to run through the boot sequence, and our eventual goal will be to have a running router, in other words, operational router. All right, so the first thing we're going to do to a router that's in the off position is turn it on. As soon as this happens, the router is going to go through its POST, which stands for Power On Self Test. Now, this Power On Self Test performs two functions. The first is a roll call for the types of hardware that you have within your router. An example of this is you're going to identify the different interfaces that exist on this router. This is where the list will come up telling you that you have so many Ethernet interfaces, so many serial, so many FDDI, and so on. Different types of hardware are going to be identified. At the same time, it's going to test the functionality of that hardware as it exists on your router. Any hardware failure will be identified in this portion of our boot sequence. All right, now we're going to move on to the bootstrap process. Now that bootstrap happens across two functions, if you will, of our model. Now the first thing the bootstrap is going to do in this first part is to find an iOS image. Now the eventual goal, obviously, is to load that iOS image. Remember that the iOS is the operating system for Cisco devices. So right here, we're just looking to find a valid operating system. At this point, Bootstrap falls a little bit short and needs the help of what is known as a configuration register. Now the configuration register resides right here. CF is what we'll label it for now. And this configuration register has many responsibilities, but one of the responsibilities is that it is going to identify where you should look to find a valid iOS. But let's go over the configuration register in more detail before we move on to that choice for the valid iOS. Let's talk about it. It's 16 bits in length, which means that you have a range of 0 through 15 in your placeholders for bits. It is also represented in hexadecimal format. All right, so that means that every 4 bits, 2 and 3, are divided and shown up as one hexadecimal character. If you recall from other discussions in our nuggets, the value of the place values here are 1, 2, 4, and 8 for binary. All right, as we convert this to hexadecimal, let's say that they were all on, so that would be 8 plus 4 plus 2 plus 1. We have a value of 15, and that is represented by a hexadecimal F. Okay? Now, any double-digit value that's represented in hexadecimal, you have to do it with one character. So that's why we have the value of 10 represented by A, 11 by B, 12 by C, 13 by D, 14 by E, and then obviously, as we just said, 15 by F. 0 through 9 are represented as they would be by the single numeric character, 0 through 9. All right, so we're going to do that for every 4. So we're going to have, with 16 possible bits here, 4 divisions. So the representation in hexadecimal could be something like 2102, which indeed is our default representation, and this is the normal, if you will, configuration register for a router that is operating in normal mode. Now for the 2 most important characteristics of the config register. The first is that it is indeed considered a router component. So the configuration register in and of itself is a router component. And the second is that it resides in NVRAM. Now NVRAM is a component also, and we're going to discuss it in more detail later in this nugget. All right, for now, let's look at our 3 choices. We said we're looking for a valid iOS, but at the same time, we've got to have a limiting number of places that we're going to look. And here we find those. The ROM monitor mode, the RX boot, and the flash memory. Now flash memory is also considered a router component and will be discussed in more detail. Now the ROM monitor mode we'll list here. We'll list the RX boot here and then flash here. ROM monitor mode is what we are going to use whenever we are looking at a low-level testing and troubleshooting type of environment. You can look at ROM monitor mode as being similar to safe mode in your Microsoft products, like Microsoft MT. Whenever you need to troubleshoot or scale back on the iOS, the operating system, and look at the low level, this is what you're going to use, the ROM monitor mode. Then we have the RX boot. This is another iOS image, very small again, and what it's mainly used for is to download iOS images onto the router. In other words, you could TFTP an image from the Cisco site onto the router using the RX boot mode. And then we have flash memory. This is actual memory that's on the box. It can be in one of two forms. It can be an Intel EEPROM, which means that it's not volatile. In other words, as you power cycle this router, this iOS image is going to stay in flash memory. And then also the other option we have, we'll have slots available on certain routers for PC MCIA cards. The little credit cards, they look like little credit cards. You slide them into the router, and they have an available space of memory, again, to store iOS images. Now we know the three valid areas that we can look for an iOS to be used by the configuration register. What we don't know is how does this configuration register point to a specific area for an iOS to be found. This is the reason that I broke out the config register and identified it as having 16 bits, 0 through 15, and those bits were divided into groups of 4 that were represented in hexadecimal. The reason for that is this low order, or these low bits here, 0, 1, 2, and 3, are what's known as the boot field. And this is the particular part of the configuration registry that's going to point to which of these areas we're going to use the iOS from. Alright, so we're going to represent the values in binary first. So the placeholder here, its binary value will be 1, this would be 2, this would be 4, and this would be 8. These are the possible values if they were turned on. They could also be off and then obviously be a 0. So for ROM monitor mode, we would need each of these placeholders to be turned off. If all of them are represented by binary zeros, which would result in a 0 for our hexadecimal character, we're going to use ROM monitor mode, which again was like safe mode for a Microsoft product. Now if we're going to have a value of 1 turned on, the others turned off, which would give us a hexadecimal value of 1, then we're going to use the RX boot. In other words, we're probably looking for another iOS image to download from some other entity onto our router. Anything else that ranges from 2, which is this 1 bit turned on, in hexadecimal, up to F, which is every bit being turned on because that equals 15, we're going to use NVRAM and what's known as the boot commands to point to a particular area to load our iOS image from, and that's almost always in flash. In fact, by default, it's the first image that we run into in our flash memory. Regardless of which one is chosen, whether it's the ROM monitor, the RX boot, or our other component known as flash memory, we're going to move into the portion here where the iOS will be loaded onto the router. So let's review really quickly what we've identified as router components so far. We have the configuration register and we have the flash memory. We also had ROM. Remember that ROM is the component, although it's not listed on our boot sequence chart yet, that is where Post and Bootstrap reside. Continuing with our boot sequence model, we now have a valid iOS that is going to be loaded on the router. The first job that this iOS has is that it needs to find a configuration file, as we've identified right here. Now this configuration file is simply stated as a list of operational parameters within your router. Let me give you an example. You can turn on or off specific interfaces within your router. You can also assign sub-interface commands. In other words, you can assign an IP address here. You can assign an IPX address. You can also turn on different types of protocols, whether they're routing protocols or route-head protocols in this configuration file. We also need to add this to our list of router components. The configuration file is a component. Now, I don't want to have any confusion here. The CF configuration registry and the C-file for configuration file. I'm simply labeling these because I don't have enough room here to write out configuration registry and configuration file. These are not official names within Cisco, and they will not be on any exam that you would ever take as CF or C-file. Just remember them in their complete name as configuration file here and the configuration registry as we were dealing with here. Although there are two types of configuration files in existence when a router is running or operational, there's only one during the boot sequence that is available, and it's going to be found in NVRAM. So as we're searching for our configuration file, luckily there's only one place that we need to look, and that is non-volatile RAM. It is another component within the router, and because it is non-volatile, it gives you a hint as to what separates it from a regular random access memory, and that is the fact that as you power cycle the router, this configuration file that's stored in this area of memory will stay resident. That is why it's part of the boot sequence. What is stored in NVRAM is known as a startup config. Okay, this is our configuration file or our list of operational parameters that we want to boot this router up with. And so, as we move into this NVRAM section, it's a simple question of either yes, it is there, and we're up and running using that startup config, or no, it's not there. And then what we have to move into is what's called setup mode. And it's simply a series of questions to get you a bare bones configuration file for the router to operate on. In most cases, you will find a configuration file in NVRAM, in other words, the startup configuration that will be used to get the router into its operational mode. So let me talk about one step here that exists right here. We just said, or I just said, that there are two types of configuration files. One is the startup configuration. It's stored in NVRAM, and therefore it is non-volatile. In other words, power cycle, we don't lose it. There's another form of a configuration file, and it is stored in what's known as RAM, Random Access Memory. Again, this is another component of the router, just like NVRAM was. Now, what we're going to store in here is called the running config. The difference between RAM and NVRAM is that RAM, when you power cycle your box, your router, you are going to lose everything that you stored in this running config. And that's why at this point of our boot sequence, when we were searching for a configuration file, we only had one option, the startup config, because we just booted the router up and running config is zeroized. There's nothing in there. All right, but at this point, in other words, in order to get the router running, we have to move everything that was in startup config into the running config. The reason for that is the router, as it's actively running, is going to use the configuration that's stored in RAM. So how do we get information then from the running config over to the startup config when we make modifications? The answer to that question lies in the next section of this nugget. That answer will be a manual answer, though. Unlike the process here, when I say that the contents of startup config have to be moved into the running config, that is automatically done by the router and is transparent to the user. And the boot sequence at this point is complete. We are running and operational, and we are running in RAM as far as our configuration entities are running. We're using the running configuration. All right, this sequence is going to be a sequence that shows the router that is already running, so we're already in the on state. We've gone through the boot sequence, and we're going to enter configuration changes at some point in this sequence, and then eventually we're going to power cycle the router and come up with our boot sequence once again, where we're going to look for a startup configuration. Now, we're hoping that our changes that we made within this sequence are taken into account in that startup configuration. Let's look at how that would happen. As I said, the router is in the on position, it's up and running, and eventually at some point after the show commands and whatever else we're doing on our router, we're going to want to make some configuration changes, whether it's for an upgrade, a downgrade, or simply we want to just roll or spin that roulette wheel to see how we're going to come out. Either one, we're going to have to enter into the configuration mode. So at this point, conf, and what we've been in many times, conf T, T standing for the terminal, so configure via terminal. At the point that we do that, all changes that are made in this space here are going to be changes that are directly affecting RAM. And the reason that they're directly affecting RAM is we are changing the running configuration. So as soon as you hit enter on any of these commands, it is taken into this config file and made not permanent, but the changes are made in this file. Again, it can't be permanent because RAM is not permanent. Semi-permanent, if you will, because it will be in existence up to the point that your router has been power cycled or lost power. All right, once we make these changes in configuration mode, eventually we will exit once all changes are complete. At that point, we have a disparity between our configuration files. Our running configuration has been modified and our startup configuration does not have the same modifications. Now, what is going to be the result of this, or the danger of this? Eventually, we might power off this router. And if we do, in fact, it will happen, it's just a matter of when. When that router is powered off and then cycled back up, and we're going through the boot sequence again, it's going to look for the startup config in that boot sequence. When it does, we will have lost the modifications made in that running configuration back here because we did not make sure that these two startup and running config files matched up. How do we do that? We do that with a copy command. Simply put, we can copy space running config space startup config, and it takes all the contents and the changes that we just made here and adapts them and puts them into the startup config. Once that happens, we are safe to power cycle our router at any point, and when we come up to the boot sequence, that startup config is going to match the running config that we left with because we saved the contents from it to the startup. In this nugget, we modeled two key processes of a router, one the boot sequence and the other the configuration changes in order to identify router components. We started off by understanding that ROM had within it the post, the bootstrap, the ROM monitor, and the RX boot. And these are functions of this one router component. Then we moved into the configuration registry and understood that it is used to point to a valid IOS, whether that is held in the RX boot, the ROM monitor, or flash memory, which is another component. Flash memory is used to store valid iOS images on the router, and it can be stored in EEPROMs or in slots with PCMCIA cards. Then we looked at the configuration file, understood that there were two types. One is the running configuration, another the startup configuration. The running configuration is stored in random access memory, which is volatile. In other words, with a power cycle of the router, we will lose this information. And then the other, the startup config, was stored in non-volatile RAM, and in the power cycle, we will keep that configuration, which is why in a boot sequence, we will use this startup configuration to start our router and move that information into RAM, the running config, so that we can continue using our router operationally. I hope this has been informative for you, and I'd like to thank you for viewing.